Today we are machining some ultra-high molecular weight polyethylene wheels for a Formula 1 in-school team. The drawings have been produced by Year 8 to 9 students and are at a higher quality than I received from professional engineers. The material has been provided as pre-cut round bar stock. This has required a bit of thought for how I was going to do the work holding. I need to produce 10 sets of wheels, which comprise of 2 front and 2 rear wheels per set. The fixture has to be quick and accurate. Making a set of soft jaws would be good for the first side, however the material is too soft and thin for the second side operation. After some testing, I landed on a vacuum fixture. For side 1, a pocket was machined 0.2mm wider than the stock diameter. A hole was drilled in the center, and then a cross hole drilled to intersect and give a path for the vacuum. An O-ring was placed on the bottom of the pocket and the vacuum connected. With the rough sawn stock, this technique works very well. However, I did try it with cleaning up the face of the stock and found that the stock would rotate while trying to machine it. The first side operations consist of facing the stock, scallop for internal fillets, adaptive toolpath to clear the internal and external walls at full depth, then external and internal contours to bring the wall thickness to the final diameter. Doing this at full depth only leaves the facing operation for the second side, hopefully making the parts as concentric as possible. Here we can see how quick the fixture is. We just take off the first part, put on the second part, click run. One issue we ran into with this technique is that there was a burr that was created at the bottom of the part here. However, this was easily removed with some pointy nose pliers and cleaned up with a blowtorch. Finally, here we have the first side completed of the rear wheel set. Minus one, of course, which is currently being machined. The second side setup required a mandrel to locate the part and hold it in place with vacuum. The machining operations for the second side included an initial facing to bring the stock down most of the way, then a scallop to machine the surface smooth, followed up by a contour to get rid of any burrs on the edges. Fitting the part to the mandrel is quite tight, so I did it off the vacuum support. And once I place it down onto the vacuum, you can see it's pulled directly down and it's securely placed on that mandrel. Here we can see the benefits of using this fixture and how quick it is to change over the parts. And it took a matter of, I think, 30 seconds to swap the parts out, and we're back machining. Well, I hope this video was interesting to someone. I enjoyed making these parts and the team did very well, so congratulations to that team, and I'll see you next time. Thank you very much.